see this problem. Show that the group velocity equals the particle velocity. According to de Broglie, a particle is in motion. A single wave is always associated with the motion of the particle, called de Broglie wave or matter wave. The wavelength of the de Broglie wave, lambda equal to h divided by mv. H is Coulomb's constant, m mass of the particle, v the velocity of the particle. If it is the case, then the de Broglie velocity, that is de Broglie wave velocity, Vd equal to nu lambda. You know that E equal to h nu, and then the Einstein mass energy relation is E equal to mc square. From these two relations, nu equal to mc square divided by h. The de Broglie wave velocity Vd equal to nu lambda. Instead of nu, if you substitute this value mc square by h, and then substitute lambda by h divided by mv, the de Broglie wavelength, we can get c square by v as the answer. De Broglie wave velocity equal to c square divided by v. This means that de Broglie waves are moving with velocity greater than the velocity of light, which is practically impossible. To solve this problem, we have to introduce the concept of wave packet. In the quantum aspect, single particle motion is expressed in terms of a wave packet rather than the wave. Suppose a particle is in motion, not only a single wave is associated with the motion of the particle, but group of waves are associated with the motion of the particle. Such waves are constituting an envelope. Such envelope is called as wave packet. Wave packet contains a number of waves. These waves are producing constructive as well as destructive interference. Finally, the entire wave packet may move with one particular velocity called as group velocity. Therefore, the velocity of the particle is equal to the velocity of the wave packet, that is group velocity. Now we have to show that group velocity is equal to particle velocity. If you think about the velocity of the individual waves, that is phase velocity. Phase velocity Vp equal to omega by k. But the velocity of the wave packet is called group velocity. Then the value of group velocity Vg equal to d omega divided by dk. Now we have to prove that velocity of the particle is equal to group velocity. Now consider a free particle. The energy of the free particle E equal to p square divided by 2m. The total energy E equal to half mv square, kinetic energy plus potential energy. For a free particle, V potential energy equal to 0. Therefore, E equal to half mv square. This is modified as m square v square divided by 2m. Multiply the numerator by m and also the denominator by m. We can get m square v square by 2m. We know that p equal to mv, linear momentum, p equal to mv. Therefore, E, which is equal to p square divided by 2m. This is the energy of a free particle. Now differentiate this equation with respect to p. You know that group velocity Vg equal to d omega divided by dk. This is a group velocity. But omega is equal to 2 pi nu. 2 pi nu. Instead of omega, we have substituted 2 pi nu divided by d into the value of k. The propagation vector k equal to 2 pi by lambda. but lambda equal to h by mv. Therefore, k equal to 2 pi by h divided by mv. That is 2 pi mv by h. This is the value of k. So here the propagation vector k is equal to 2 pi by lambda. K equal to 2 pi by lambda, but lambda equal to h by mv. Therefore, k equal to 2 pi by h into mv. This is the value of k. Now, instead of k, we have to substitute 2 pi mv divided by h. This is equal to d of 2 pi h into nu divided by d of 2 pi mv. This h goes to the numerator. Here 2 pi h nu. See this 2 pi get cancelled. We know that E equal to h nu. So d into E. H nu is our energy. M is our momentum. So dv. Then group velocity Vg equal to d by dp. For a free particle, E equal to p square divided by 2m. Then dE by dp, differentiate this equation with respect to p, is 2p divided by 2m, which is equal to p by m. We know that p equal to mv. So mv by m, which is equal to v. Now we have proved that group velocity Vg equal to v. That means group velocity equal to particle velocity. The particle is moving with the velocity of the wave packet. Here group velocity is velocity of the wave packet. This is for the non-relativistic case. Now for the relativistic case, we have to prove that Vg equal to v. For the relativistic case, the expression for energy is E square equal to c square p square plus m0 square c power 4. This is the value of energy for the relativistic case. You know that m is equal to m0 divided by root of 1 minus v square by c square. m0 is the rest mass, m is the moving mass. Suppose a particle is moving with velocity appreciable to the velocity of light. The mass is not a constant, it is also a variable. Here m is the moving mass, m0 is the rest mass. This is a relation connecting rest mass and moving mass. Now squaring on both sides, we can get m0 square divided by 1 minus v square by c square. This is equal to m0 square divided by c square minus v square whole divided by c square, that goes to numerator. Now cross multiply m square into c square minus v square is equal to m0 square c square. M square c square minus m square v square is equal to m0 square c square. M square c square equal to m0 square c square plus m square v square. Now multiply both sides by c square. We can get m square c power 4, which is equal to m0 square c power 4 plus m square v square c square. We know that E equal to mc square. Therefore, this is E square. E square equal to m0 square c power 4. M into v is our p. M square v square is p square. Therefore, plus p square c square. we have had this relation. Energy of a free particle in the relativistic case is E square is equal to c square p square plus m0 square c power 4. Now the group velocity Vg equal to d omega by dk, which is equal to d by dp. Now differentiate this equation with respect to p. 2e into dE by dP, which is equal to c square is a constant, then 2p into dP by dP 1, so we may remove that one. C square is a constant, 2p into dP by dP, that is 1. This is a constant, if you differentiate this, 0. Then dE by dP, which is equal to c square into p divided by e. See here, 2 get cancelled, d by dp equal to c square p divided by dc. Now we have to replace this p in terms of momentum. dE by dP, which is equal to c square into m into v, that is m0 divided by root of 1 minus v square by c square into v. P equal to mv, but m is equal to m0 divided by root of 1 minus v square by c square. Here E equal to mc square, that logic we have to use. It is mc square means m0 divided by root of 1 minus v square by c square into c square. Here instead of E, this should be replaced by mv, this is replaced by mc square. But m is equal to m0 divided by root of 1 minus v square by c square, because this is relativistic case. Here also, in terms of mc square, we have to write E should be replaced by mc square. M is expressed in terms of m0 divided by root of 1 minus v square by c square. Now we may cancel these things. We can get dE by dP, which is equal to v. This is actually our group velocity. Therefore, in the case of relativistic aspect also, group velocity equal to particle velocity. In the non-relativistic limit, the velocity of the particle is equal to group velocity. In the relativistic limit also, velocity of the particle is equal to the group velocity.